Hi there. Today we're going to be doing domain and range, and we're going to be focusing on continuous functions. Make sure you take notes as you go and complete the survey that follows. All the graphs on here, just do a nice rough sketch of them. So what we're going to be doing with a continuous function, so just to review that, continuous are unbroken and they're continuous, you can't break them apart. And so with the discrete functions, we use the set notation. For continuous functions, we use something called inequality notation. And so just to recall, domain is how far left to how far right we're looking. And so we're going to write it where the number on the left is going to be the farthest left. Then we're going to have an inequality of some kind. The domain represents the x values. We're going to have another inequality of some kind, and then we pick the number that's farthest to the right. The range is how low to how high. And so for this, we're going to look at what's our minimum point? What's the lowest point? Then we're going to have an inequality, and range represents our y values. Then we're going to have an inequality, and then we're going to have our maximum point. So we have those two different types of inequalities that we can be using in our inequality notation. The rule of thumb for these is we're going to be using the less than or equal to or the great on both sides if we have exact numbers, and we're going to do inequality notation if they cannot be inexact, and I'll show you what that means in a moment. So here's our first one. Make sure you're writing this down. We're going to use inequality notation on a problem like this. Okay, so here's our graph. It is continuous because there's no broken pieces in our graph. And so the first thing I want to do is find my domain. Now, domain represents the x values, so I'm kind of like focusing on my x-axis. And what I do is I look farthest to the left first. And so if I look farthest to the left, I have this value here. And so I look directly down and I see the farthest left is -3. So that's my first number. Now I want to see, is this an open or a closed circle? Am I including the number -3? And I can see from this, yes, I am. So since I'm including it, we remember when we include things, we draw the line underneath. So I'm going to do less than or equal to. Again, the domain is the x values. Then I'm going to look at the farthest right point. Well, the farthest point to the right, I'm going to say, okay, I see here that I'm including it. So it's going to be a less than or equal to. And then the lowest point here is the number 2, or the highest point, sorry, farthest right is the number 2. And so my inequality is going to go from -3 to 2. And what that's saying is that all these values from -3 all the way to 2 are possibilities for a point on this line. Let's do the same thing with the range. Now the range is the y values, and that's going to be the minimum point to the maximum point. So for the minimum point, I see the lowest part here is 1. So that's the first number. Always going to be less than or equal to for these symbols here. This is the smallest point and it's included, so it's a less than or equal to. Remember, range is y, so we're going to put a y in the middle. And then I'm going to look at my highest point where a is. It's included, so I'm going to put a less than or equal to. And I see the highest point. I know it doesn't look as obvious, but it is the number 4 because I know the number is missing. So that's how we do our domain and range for a graph. Let's take a look at another example. So in this one, we're going to do a circle, and we're going to repeat that same process. So we're first going to start with the domain. What you might want to do is use a pencil and draw it up against the edge of the circle or whatever graph you're going to be using. And you can see where is it crossing the x-axis. And in this part, it's the -1. So that's my first one. Then from here, I'm going to decide, is it including that number or not? And it is. So I'm going to put it less than or equal to because it includes the -1. Domain is x. So now I look at my farthest to the right point and I see it's hitting here at 5. It's including the number 5, so it's less than or equal to 5. Now I'm going to do the range. So I'm going to take my pencil and put it right up against the bottom of this circle, and I see that it's hitting the y-axis at -3. So that's my lowest point. It's including the -3, so I'm going to put a less than or equal to. Range is y, and then I'm going to go for the highest point. The highest point is included and it hits the number 3. So you want to kind of use your pencil or a piece of paper and see what's kind of going on with my lowest to highest or left to right. All right, here's our next one. This is a very special one, so make sure you have this written down. So let's start with domain. We're going farthest to a left. So once again, I'm going to take my pencil and go up against the very beginning of this graph. But what I'm seeing is going on at this graph is that it's hitting an arrow, and that's very special. When it hits an arrow, that means technically this can keep going, and it goes on forever and ever and ever into the negatives. So that represents negative infinity. Now we can never ever get to negative infinity if we were ever to count. So we can't include that in our domain. So what we do is just say less than. Just like the other ones had less than or equal to because we included the numbers, this one does not. Domain is x. And then on the right-hand side, once again, I'm hitting an arrow. And so I'm not going to include it, but it is going to go all the way up to positive infinity. So anytime your pencil hits an arrow, that means you're going to infinity. Just depends on if it's negative or positive. This is the negative x-axis, that's why it's negative infinity, and that's the positive one. Now looking at the range, a little bit different. The lowest point isn't an arrow, it's a number, it's 0, and it's included. And these are our y values, but the highest one hits 2 arrows. And because the highest one hits 2 arrows, we're going to have a less than and then an infinity. So we can have one with an inequality and one without. Last one we're going to do, same process. Why don't you give this one a try? If you went through and did it, you should have got negative infinity to positive infinity because we would hit arrows in both spots. And then the range would be negative infinity to positive infinity as well because we hit an arrow in both spots. So remember, domain is x and your range is y. Use your inequality notation on continuous graphs. The less than or equal to is used for exact numbers, and the less than sign is for the non-exact, like the infinity. And we use that when we hit our arrows. Here's your survey. Please make sure you complete it, and I'll see you tomorrow.